This lesson helps you understand the vertical asymptotes of rational functions. A rational function is a ratio of polynomials. For this course, we'll limit ourselves to functions where the numerator polynomial is a constant. To graph a rational function, you need to understand what the graph looks like near points where the function is not defined. Since division by 0 is not defined, any value of the x variable that makes the denominator equal to 0 is an excluded value. This means that the value is excluded from the domain of the function because the function is not defined for that value. To find the excluded values of a rational function, set the denominator equal to 0 and solve for x. In this case, add 2 to both sides, and the excluded value is x equal 2. And you can see that this is true. If you substitute x equal 2 into the function, you get 2 minus 2, which is equal to 0. And so the function is not defined at x equal 2. For the first graph, let's look at the parent function of all rational functions, y equals 1 over x. For this function, notice x equals 0 is an excluded value. So it's not defined at x equals 0. But at x equal 1/2, the function's equal to 2. At x equal 1, the function's equal to 1. At x equal 2, the function's equal to 1/2. And at x equal 3, the function's equal to 1/3. For negative values of x, the points are symmetrical. At x equal negative 1/2, the function's equal to negative 2. At x equal to negative 1, the function's equal to negative 1. At x equal negative 2, the function's equal to negative 1/2. And at x equal negative 3, the function's equal to negative 1/3. Now, draw a curve through the points. Notice, however, you can't draw the curve joining points across the origin, since the function's not defined at x equals 0. So draw two curves, one curve through the points on the right, and another curve through points on the left. If you draw a vertical line at x equals 0, the excluded value, notice how the graph behaves. From the right, it curves up towards the vertical line, getting very close but never touching. It's the same from the left. The graph curves down towards the vertical line, getting very close but never touching. This is a vertical asymptote, or VA, of the function. The graph of rational functions always look like this near their VA. The graph curves up or down towards the vertical line, getting infinitely close but never touching. This behavior near the vertical asymptote is easy to understand. Recall what you know about fractions. When the denominator of a fraction gets smaller, the value of the fraction gets larger. For example, here are the values of the function from x equal 3 to x equal 1/10. Notice that as x gets smaller, the value of the function gets larger, from x equal 1/3 to x equal 10. So as the graph of the function gets closer to the VA, at x equals 0, the graph gets larger, curving up or down towards the VA, getting close but never touching. So the value of the variable that makes the denominator of a rational function equal to 0 is an excluded value. For rational functions in this course, there's a vertical asymptote at the excluded value. So for the parent function, there's an excluded value and a vertical asymptote at x equals 0. For the function y equals 1 over x minus 2, there's an excluded value and a vertical asymptote at x equals 2. For the function y equals 1 over x plus 3, there's an excluded value and a vertical asymptote at x equals negative 3. And in general, for the rational function y equals a over x minus b, x equals b is an excluded value and a vertical asymptote of the function. For the graph of a rational function, a vertical asymptote, or VA, is a vertical line at x equals b. Near the VA, the graph of the function curves up or down towards the VA, getting infinitely close, but never touching. This lesson has been brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.